It's the engineer from Shuttle Obi-Wan checking in. Wanted to talk about the Big Bang. The supposed Big Bang. You can't see them, but there's bunny fingers. Anyways, so what's wrong with the Big Bang? Let's start with how it's presented, how it's perceived. Every time you see a video of a Big Bang, there is blackness, and it's everywhere. And then from the center of the screen, it explodes. And this is a misrepresentation, because it's contrary to what we know about the expanding universe, and it's also, it doesn't involve theoretical reality, which is to say that beyond the distance that we can see in our universe is more universe. Because they say that the light has been traveling for 13.7 or 8 billion years. So what we're seeing has moved on, number one. But at the same time, it was a uniform explosion. So yes, everything was different at the creation. Maybe there was a great deal more matter being not. See, the difficult thing is that we have what we know as matter, and condensed matter would be something like lead. But what I'm talking about is more like a black hole. And then also what we're seeing at the edge of our visible universe. The basic building blocks of things like quarks and electrons and the bosons and all of this stuff that makes up atoms and our reality. Back when that stuff hadn't gotten together to make up more complex matter, so we have this soup, this very different universe, a smaller universe, because what we know of the atom is there's a lot of space there. And so we're put together on a particle level. We're put together with a lot of space. When we look out into the universe, we see a lot of space, and we see these forms and flows of matter that are entire galaxies, and light shining in this array or spread, as if somebody blew up a water balloon in slow motion. And that's consistent with what we know of how matter works. But if we go back to the beginning, with all this subparticle and this energy, this soup of energy, it was fairly uniform. And if we think about how our matter has been constructed with the gravity of stars collapsing the hydrogen and burning hydrogen and turning that into additional elements, heavier elements, and then finally exploding, and those elements spreading out across the universe. Let's go back to hydrogen and the proton and the electron, and how those might have been made on smaller scales with quarks and bosons and micronovas that probably perpetuated this spacious universe. And then the spacious universe of hydrogens creating complex atomic structures and molecules. when stars went kablooey. So this micro universe that was uniform, and let's theorize that it was also, or is also, infinite, as is our universe. So instead of seeing a little dot explode from the center of your screen, light was suddenly everywhere. And very likely some kind of chain reaction set it off to do so. But every point, at more or less the same time. Now we say more or less because it wasn't exactly at the same time, as we see in the fluctuations in the microwave background radiation. We know that it's already starting to congeal into these different forms and shapes that go black. They stop emitting, and they start, with gravity, they start collecting. Or congregating to form what we're going to be seeing as the first stars, because we are looking into the past when we look further away. So we see the history of the universe unfolding in front of us, but further and further away. And it continues to go further and further away because the light is moving towards us from such a great distance. But it's changing. And it's taken 13.7 billion years for us to get to where we are now here in the present. And no one person is going to be able to sit for that long and watch the edge of our visible universe go through the changes that will eventually lead to something like what we see here. But we can see the process moving from there to here. And we can presume to know that what is happening here is happening there, or at greater distances, and everywhere in between. And the acceleration is an illusion, because we see things from a certain perspective. And again, along the lines of being misled or viewing things incorrectly, we have a distorted view of the universe. Nothing is where it appears to be. It's all moved on because we're seeing the past. And if we were to view the Big Bang accurately, we would see light everywhere, and we would probably look at it in a time lapse. It's brilliant everywhere as matter starts to shape. As matter starts to take shape. Pardon me. Getting a little late here. So as matter starts to take shape across the universe, it is also moving away. Or the universe is expanding, I should say. The universe is expanding with matter inside it. The universe is stretching, gravity starts to take over, and we start to see these threads of connectivity that develop to create the first stars, the first galaxies. Which is interesting because black holes are awesome. So you need to, when did they happen? We have these pitch black, the dark area between that initial brightness and then the first set of stars. So matter's doing something, and then the hydrogen ignites. And so we get stars, and then the development of galaxies, or they're a nebula that are sparking. It's a field of interest I'd like to delve into further to see what's going on at those early stages. And we have satellites going up that are going to be exploring deeper and deeper, more sensitive equipment to view those early years of the universe.